Welcome to the CompTIA A+ 220 1101 exam or Core 1 exam. This is Objective 3.4, CPU features. Most of the latest operating systems are 64-bit architectures, but you might find older operating systems still running that are 32-bit architectures. These are referring to the architecture of the CPU that is running on the motherboard of that system. And usually it's either a 32-bit or a 64-bit architecture. A 32-bit processor can access the number 2 to the 32nd power. That's just over 4 billion values that it can store when it accesses information in that operating system. Well, if you have a 64-bit processor, it can store a lot more information than that. You would take 2 to the 64th power and you would end up with this very large number. If you were to look at this on how much memory you can store in a system, a 32-bit processor can access 4 gigabytes of information, whereas a 64-bit processor can access almost 17 billion gigabytes or around 16 terabytes of information. That doesn't necessarily mean that the 64-bit operating system you're using right now can access that much, because most operating systems will have a maximum value for the OS that's already defined. But these are the physical limitations. If you want to see the system type in your Windows system, you can go to the control panel, look at system settings, and it will tell you what kind of processor you're using. Hardware drivers that you install must match the type of operating system you're using. So if you're using a 32-bit operating system, then you need to use a 32-bit hardware driver. If you have a 64-bit operating system, then you need, in the same thing that's parallel, you would need a 64-bit hardware driver as well. Sometimes you'll see this 32-bit software abbreviated as x86. You'll find this in Windows environments under Program Files. However, if you look above here, Program Files by itself is a 64-bit folder, and the x86, like we said, is for 32-bit. Depending on the type of application, there will be backwards compatibility. You can look and see what's been installed in your program folder and see what kind of programs you have. Let's talk about ARM. There's another family of operating systems called the Advanced RISC Machine, or we say ARM. This is an architecture that was developed by ARM Limited. They designed the specifications for the hardware, and then the third parties use those specifications to create ARM-based CPUs. The ARM architecture is well known for being extremely efficient and fast in its processing. It uses a lot less power and a lot less heat. It's ideal for mobile devices. Although we commonly see ARM used for mobile devices and Internet of Things devices, the capabilities of ARM-based architectures are greatly expanding these days. And we're starting to blur the lines between the traditional 64-bit operating system and the ARM-based operating system. Ironically, the computer I'm using right now indeed is an ARM system because it's a Mac Mini. We often refer to a CPU or a central processing unit as a single monolithic device. All the information goes into the CPU and then we get results out of the CPU. But inside the CPU there are individual components. The main processing of a CPU occurs on the processor core. Take a look at the cores right here in this picture. These are physical packages. Sometimes we refer to these as like dual core, quad core, octa-core, multi-core. We use so many cores in our CPUs today, it's going to expand in the future. Maybe 10 core, 12 core, 20 core, 40 core will be available in no time. It's not unusual for multi-cores to also have multi-caches. These might have the caches that are dedicated for a core, or they might be shared caches that are used across the cores. These caches are designed to help speed up the processing of information that go inside and out of the CPU. If you were to look at a close-up of the CPU itself, you can almost make out where the different components and devices are on a single CPU. If we looked at this broadly, we can see that there might be individual cores on the CPU. There's probably a cache that is shared between all of the cores. And the CPUs today also tend to have their own memory controllers and graphic processors built into the CPU hardware. We do call these like GPUs, and you can find them on some processors today. If you start monitoring the amount of processing occurring on your CPU, you might see images like this in an application. Such as like inside a Windows task manager, you might see how many cores you have, and it will tell you if cores are virtual or not. This is called hyperthreading. Hyperthreading technology has been around for a while and has greatly influenced how computers work today. You can have one central processing unit, but the computer thinks that there's two, and it will perform better. You will see improvements up to 15, maybe even 30% improvement. Not only do you need a CPU that supports this hyperthreading, but your operating system also has to support it as well. Today, most modern operating systems do support it. Like I said, it's been around for a while, and as long as you have an operating system that is Windows XP or later, you should be fine. Many CPUs also include hardware that allow us to virtualize additional operating systems on our computer. This means that we could load Windows as our primary desktop, and inside of the Windows we could run other Windows instances or instances of other operating systems such as Linux. Virtualization itself is resource intensive. So it makes sense that a lot of this functionality that normally would be in software and put directly on the hardware of the CPU. If you have an Intel processor in your system, you can check the BIOS and see if it supports the Intel Virtualization Technology, or VT. Have it down here. Or if you use an AMD processor, you would use what's called AMDV, or AMD virtualization. Some virtualization software requires you to enable these capabilities in your CPU. So check documentation of your hardware and your BIOS and make sure that it's enabled. Okay, we are at the end of the objective. Here's a pop quiz. On which device are we most likely to find an ARM processor? A, get my pointer. A Windows corporate file share server. B, a PlayStation gaming console. C, a Dell XPS laptop. Or D, an ADT home security CCT system. Please be careful, I did say most likely. Well, if you think about the smaller devices that connect to the internet, you're most likely going to pick a CCTV system. These are small devices, they don't need much, they just need a basic connection and a processor. So that's most likely going to have those. Although you do find that, as we said, ARM processors are becoming more and more common. Maybe in the future we will see servers, Windows servers that have ARM processors. Maybe you'll see a gaming system that has an ARM processor. I don't think you would see a high-end laptop like a XPS with that kind of processor, but who knows? Thank you for watching.